the Lane Water Cafe. Today in the cafe, we're going to be taking a look at reverse osmosis systems in the power generation industry. If you happen to be joining us in the cafe today simply by podcast, I'd like to encourage you to download the slidecast at www.slideshare.net. Simply enter the keyword Lane Water and you should be able to find this presentation. In power generation, the predominant use of reverse osmosis is in the area of boiler water, feed water pretreatment. So the RO system in this particular application then comes downstream of clarification and filtration, but upstream of demineralization and polishing. One thing to note is that your RO equipment performance, how well you design this, is going to directly impact your demineralizer performance and also acid and caustic usage, which can be of considerable magnitude in the power generation industry. Before we head into the details of actually designing reverse osmosis and those key considerations, I want to talk just very briefly about what reverse osmosis is, where it comes from, and kind of the fundamental principles of how it works. So you may remember from chemistry class that osmosis is when a pure liquid, in this case water, diffuses from the dilute side to the concentrated side of a system that has been separated by a semi-permeable membrane. So reverse osmosis simply means that we are going to reverse the flow and make highly concentrated liquids disperse through a semi-permeable membrane to create a purified liquid on the other side. To do this, you need a high pressure system. Typically, in a reverse osmosis system for the power generation industry, you're going to be talking about somewhere between 200 and 450 psi to get that job done and to get enough volume to really make it worth your while. So there's four key considerations, four components to an RO system. Those are the element, the array, the stage, and the pass. So let's take a look at each one of these in more detail. Element. There are really four basic types of elements: spiral wound, hollow fiber, large tube, and flat plate. Each of these has its own advantages and disadvantages, and I encourage you at the end of this slidecast to go ahead and download the white paper where all of this is explained in much, much greater detail. An RO array is really just how the elements are grouped together. Typically you're going to see these in series or in parallel. An RO stage is defined as a series of elements linked together such that the reject, that's the concentrated water, from the first stage becomes the feed water for the second stage. The reason this is done, the reason that reverse osmosis systems are staged, is to reduce the amount of wastewater and to increase what is known as the total recovery from the RO array. So here's an example of a two-stage reverse osmosis system for the power generation industry. As you can see, feed water is coming in. That first stage has two membranes in parallel. The reject from those first stage membranes is being fed in as feed water to the second stage. The product, the final product from both the first and second stages, is being combined and is heading off to be used in the system, where the reject, again combined, is going to waste. Now, the final thing is then, what is a pass? How do we define an RO pass? And this is an arrangement of elements where the permeate, okay, that's the clean water, if you will, the purified water, from the first pass becomes the feed water of the second pass. Now this is different than what we looked at in that two-stage example, because here what you're really going after is not a reduction in waste, but rather an increase in the purity of the final product or permeate. So in figure 2, we can see a two-pass, two-stage RO system, a pretty common type of arrangement where you get a little bit best of both worlds. You reduce the amount of waste because it's a two-stage system. You increase the quality of that permeate because it's a two-pass system. In some cases, you'll want to take this out to 2 or 3 stages and or 2 or 3 passes, depending upon your particular application. Here we can look at a slide that shows the effect on permeate quality of using multiple passes. So we're starting with a feed water with a conductance of 400 microsiemens per centimeter, and by the end, the final permeate leaving the third pass is down to 14 microsiemens, a very, very dramatic reduction. Looking now at stages, again, why do you use a stage? You use a stage or multiple stages to reduce the amount of wastewater generated. Here you can see, starting with the same water, 400 microsiemens per centimeter, you are taking a flow rate of 400 gallons per minute, and by the end, the amount of reject coming from the third stage is only 7.5 gallons per minute. But you can see that the conductance has increased from 400 all the way up to 21,320 microsiemens per centimeter, which is approaching that of brackish water, so pretty concentrated stream. I know this has been very quick, just a broad overview. There is a ton more detail in the white paper. I encourage you to go download that now. White paper is entitled Reverse Osmosis Design for the Power Generation Industry, What You Need to Know. And again, chock full of details. I believe this paper is about 11 pages long. You can get it by clicking on the link in front of you, or if you happen to be watching this as a video, you can simply go to the URL at the bottom of the screen and receive your copy. So why Lane Christensen for your power generation reverse osmosis system? It's a great question. Quickly, 4 reasons why. One is the complete array of filtration options. Since reverse osmosis is rarely a standalone system, having a company that can handle all the treatment functionality from clarification through granular filtration all the way through the reverse osmosis process is a big plus. Hydrology. Evaluating the incoming water streams, locating new water streams for you. Lane has that down pat, has been doing it for close to 100 years. Well drilling. You need a new source of water? We've located that source for you. Now we can drill the wells and put in the piping infrastructure to bring that 50 feet to 500 miles, whatever the job, no job too big or too small. Thanks again for joining us at the cafe today. It's been a pleasure. Look forward to you coming back and joining us again. Bye now.